Good morning. Good morning.
Good morning, sir.
Hello. Okay, very good morning. Uh, I think 10 a.m. is right. We will wait for 2 minutes. Many of the students still joining our lecture. I will present the screen. His screen is visible to all.
Yes, sir.
In first 5 minutes, we will take a recap of the syllabus that we have covered in last lecture. Up to that time, whatever the remaining students, they may join our class. As far as the third chapter is concerned, his voice is clearly audible to all. Hello.
Yes, sir.
Yes, sir.
Okay. The third unit is hydraulic circuits. Hydraulic circuits are nothing but it is a combination of different hydraulic devices in order to achieve certain mechanical work in a specific mechanical application. It may consist of pumps, filters, pressure controlling valves, direction controlling valves, flow control valves, certain kind of pressure measuring devices, flow measuring devices, temperature measuring devices, and at last the actuators like cylinders, motors, right? Likewise, in a hydraulic circuit, we discuss the simple circuit where it consists of a reservoir, filter, pump, motor, pressure relief valve. It will operate at a set pressure for overall the system. Then shut-up valve, it will allow the flow for a particular time only to measure the pressure. Then direction control valve, it may have a different position and a different number of ports. And lastly, actuator. It is the simple circuit. Then we see the speed control circuit in which we have studied meter in circuit, meter out circuit, and bleed off circuit. These three circuits are related to the movement of the piston or speed of the piston within the cylinder. The speed of the actuator can be controlled by providing these three types of the circuits. These are differing with each other with the position of a flow control valve, variable flow control valve, where it is to be located. At the inlet of the cylinder, then meter in. At the outlet of the cylinder, meter out. And in a bypass line, then bleed off circuit. Are you getting? We see all the diagrams related to bleed off circuit. Then regenerative circuit. Regenerative circuit, in all the circuits, those we have studied previously, that is the meter in, meter out, bleed off circuit. Whatever the discharge from the cylinder, it is directly drained to the reservoir. But in case of the regenerative circuit, whatever the discharge from the cylinder, right, this is the discharge, this will be the inlet, this will be the discharge from the cylinder. Instead of passing to the reservoir, it will be combined with the discharge from the pump. So that large amount of fluid, it will be supplied it will be supplied at the inlet of the cylinder. Means in a regenerative circuit, it is to be used when you have to increase the extension speed of the actuator of the piston. At that time, you go for the regenerative circuit. Then in last lecture, we discussed about the sequencing circuit. Its name itself indicates its meaning. That is, a sequencing circuit means in a sequencing circuit, we are sequencing the different operations. After completion of the first operation, then and then only second operation it will be started. This sequencing circuit, it is based on two parameters. First one, that is how much pressure is to be built up. It is called as a pressure dependent. And second one, how much distance is to be traveled by the piston. So it will become under the travel dependent sequence control circuit. In this diagram, we see that there are the two cylinders. Both are the double acting cylinder. After completion of the first stroke or first operation by using the first cylinder, then and then only whatever the fluid coming to the second cylinder, it will be carried out. Means when you have complete the first operation, at that time this piston it is at a outermost position. Then whatever the fluid supplied by the pump, its back pressure is to be generated. Then that fluid is passed to the second cylinder to perform the second operation. But this second operation, when it is to be started? When the first operation is to be completed and back pressure is to be generated. Then and then only second operation is to be started. So this circuit is called as a pressure dependent sequence control circuit. म्हणजे याचा अर्थ काय की पहिलं ऑपरेशन कंप्लीट झालं आणि आपण पंपकडून प्रेशरायझर फ्लुइड त्या सिलेंडरला पाठवतोय. पहिलं ऑपरेशन कंप्लीट होणं म्हणजे काय, हा पिस्टन लेफ्ट कडून राईटला एक्स्ट्रीम मोस्ट पोझिशनला येणे आणि हा पिस्टन रॉड आहे हा इथपर्यंत येऊन थांबणं. बरोबर आहे का? म्हणजे पहिलं ऑपरेशन झालं. नंतर तर काय पिस्टन पुढे जाऊ शकत नाही. पण आपण कंटिन्युअसली पंप कडून ए पोर्ट कडून इकडे फ्लुइड देतोय. इथं काय होणार आहे, बॅक प्रेशर जनरेट होणार आहे. मग हा फ्लो इकडे जायच्या ऐवजी तो इथून कंट्रोल फ्लोच्या मार्फत फ्लो कंट्रोल वॉलच्या मार्फत इकडे सेकंड सिलेंडरला जाणार. म्हणजे ज्यावेळेस हा कम्प्लीट होईल स्ट्रोक त्यावेळेस इथं बॅक प्रेशर जनरेट होणार. बॅक प्रेशर जनरेट झालं की इकडून येणारा आणि इकडून येणारा फ्लो सेकंड सिलेंडरला जाणार बाय सेन्सिंग द पायलट सेन्सर, राईट, and that will be given to the second cylinder in order to perform any second sequential operation. It may be here we perform the drilling, here you may perform the clamping, right? So by sensing the back pressure only, the pressure generated after completion of the first operation, by sensing that pressure only, the second operation is to be initiated. So this circuit is called as a pressure dependent sequence control circuit. And the second type, that is the travel dependent. Travel dependent म्हणजे काय, ह्या पिस्टन ठराविक फ्लो पाथ कव्हर केला की लगेच दुसरं ऑपरेशन इनिशिएट झालं पाहिजे. आता ह्या डायग्राम मध्ये सेम तसंच आहे. पंप कडून फ्लो येणार आहे, पी पोर्ट कडून ए पोर्टला येणार, ए पोर्ट कडून इकडे जाणार लेफ्ट हँड साइड पिस्टन हेड साइडला. हा पिस्टन पहिल्या सिलेंडर मधून राईट साइडला मूव्ह होणार. हा जसं का पुढे जाईल, थोडं अंतर पुढे आल्यानंतर हा कॅम काय करेल, ह्या रोलरला पुश करेल खाली. त्याच्यामुळे काय होणार आहे, हा जो ही जी पोझिशन आहे ही ऍक्च्युएट होणार, ती इथे येणार. म्हणजे काय, ही लाईन कनेक्शन जोडलं जाणार. म्हणजे ज्यावेळेस हा पुढे जाईल, हा कॅम ह्याला पुश करेल, तेव्हा ही पोझिशन ऍक्च्युएट होईल. हा एरो ह्या ठिकाणी येईल. म्हणजे इकडून येणार फ्लुइड आता इकडे जाता जाता कुठे जाणार आहे, इथं येईल. हा एरो इथं ह्याला कनेक्ट करेल आणि इथून हे सेकंड ऑपरेशन. म्हणजे ठराविक डिस्टन्स कव्हर राहिल्यानंतर second operation initiate. Right? Means in case of a travel dependent sequence control circuit, along with the 4/3, right? 4/4/3 position control direction control wall, you must require to have 2/2 direction control wall, and it is operated by a cam and roller. This will be the roller and this will be the cam, right? And along with this 2/2 direction control wall, there will be a check wall or non-return wall. It allows the flow only in a left hand side direction. It does not allow the flow from left to right. It will be blocked, but it allows the flow from right to left. Means in second position, when we are shifting this B knob, at that time, whatever the fluid coming from the P, it will be connected to the B. From B, it will be passing on the right hand side of the piston, that is the piston rod end of both the cylinder. Piston is moving in a reverse direction. Because of the reverse movement of that piston, whatever the fluid present on left hand side of this piston, it will be coming out to A port to tank, T for tank. Similarly here, whatever the fluid from the left hand side of this piston, it will be coming here, it is to be blocked, then it will be passing through the check wall. It will be a one direction or non-return wall. It allows the flow of fluid from right to left, and then again it will be combined with this, and this will be to port A to port T. Is it clear up to a sequence control circuit?
Yes, sir.
Anybody please reply. Can I ask a question? Okay, nice pen today. Huh? 40. You have to improve the strength also. 40, it is again 50%. Huh? 80, 70 to 80 students are there in our class. Okay. Up till now, we have covered up to a sequence circuit. Now today's lecture, we will go for the next type of the circuit. Is it clear, or any circuit is required to repeat its explanation? Hello?
No, sir.
Okay. Now we will continue next circuit. The second circuit, that is a synchronization. Synchronization circuit, where it is to be required. If we are considering, these are the two cylinders, right? This is the first cylinder. This will be the second cylinder, right? If we are not coupling the rod of the cylinder, this will be the mechanical couplings here, right? These are the two cylinders which are kept in a series, and we are providing the pressurized fluid from pump to A to first cylinder, A to second cylinder, right? If this cylinder, on this cylinder we have a load of 10 kg, and on this cylinder we have a load of 5 kg, then which cylinder it will be move faster? Yes, या सिलेंडर वरती वजन फक्त 5 kg आहे आणि याच्यावरती 10 kg आहे, तर पहिलं सिलेंडर फास्ट मूव होईल का दुसरं सिलेंडर? हॅलो,
10 kg वाला
हा
10 kg च फास्ट मूव्ह होईल.
ज्याच्यावरती लोड कमी आहे तो फास्ट मूव होईल, बरोबर आहे का नाही? बट देयर आर सर्टन ऍप्लिकेशन where we require the simultaneous movement of the both the cylinder irrespective of the load which will be on each cylinder. लक्षात येत आहे का? सिंक्रोनायझेशन सर्किट कधी वापरतो आपण की ज्या वेळेस दोन्ही पिस्टनची मुवमेंट आपल्याला सारखीच पाहिजे, सायमल्टेनियस पाहिजे, सेम पाहिजे. त्या सिलेंडरवरती किती लोड असो, इरिस्पेक्टिव्ह ऑफ अ लोड ऑन दॅट सिलेंडर, whenever we require to move the piston simultaneously, at that time you take a option of a synchronization circuit, and in synchronization circuit the piston rod of both the cylinders are connected by using a certain mechanical coupling. This will be the mechanical coupling, right? Now how it will be operating here, below part, now you are well known about there will be pump, pressure relief valve, filter, a reservoir, setup valve, and any pressure measuring device. Above that there will be a direction controller. If you are considering the synchronization circuit, it consists of a reservoir, filter, pump, pressure relief valve, right? That was not shown in this diagram. This is the lower part of that diagram. Then this direction control valve, right? Which type of this direction control valve? Which is the type of this direction control valve? Yes.
Solenoid operated 4x3 direction control valve.
Right, this will be the solenoid operated, because this line it will indicate solenoid operated. Spring return, right? Spring return. 4 port, which are those? P, T, A, B. 4 port. And how much position? 3 position, because it consists of 3 squares. 1, 2, and 3. So this is the 4x3 solenoid operated direction controller. Again, it consists of the 2 cylinders, cylinder 1, cylinder 2, and coupling, mechanical coupling. This coupling, it will connect piston rod of first cylinder with the piston rod of a second cylinder. If you are considering this diagram, the port A, it is connected to the piston side of the cylinder of first cylinder. The same flow it will be divided, right, to the cylinder second, piston side of the cylinder second. This will be the port A. And port B, it is connected for the whatever the fluid coming from the rod end of the first cylinder and rod end of the second cylinder, it will be combinedly passed to the port. Now this will be the central op position. Whatever the fluid coming from the pump, it will be passed to the tank or reservoir. There will be no actuation of the piston within the cylinder. This will be the central position or null position or op position, it will be called as. Is it clear? Now, when we are actuating this position one, what change it will be there? P is connected with A. Whatever the fluid coming from the pump, now it will be connecting, passing to the port A. And whatever the fluid coming at B, right? B, it will be connected to the tank. That will be passed to the tank. When this position is in action, at that time, the pressurized fluid from the pump, it will be passing from port P to port A. And from port A, it will be divided and it will be passing to the first cylinder partially and passing to the second cylinder partially. Now what happened? Now here we are keeping the load 5 kg, here we are keeping the load 10 kg, right? मग आता इथं फ्लुइड येणार आहे, हे हळूहळू 5 kg लोड इथं आहे ह्या सिलेंडरवरती, म्हणजे हे लिफ्ट करायला बघणार आहे, राईट? पण इथं काय केलंय आपण, त्याला कपल केले दोन्ही पिस्टन रॉड, मग हे लिफ्ट होणार नाही. ह्यातनं जे काय आता सरप्लस फ्लुइड येणार आहे ते पुन्हा रिव्हर्स कुठे जाणार आहे, ह्याच्याकडे. So sufficient pressure is to be built up in a first cylinder in order to raise the 10 kg of load. then and then only these two cylinders are moving simultaneously in upward direction. Why it is possible? Because we are coupling this piston rod by using certain kind of a mechanical arrangement, or it will be called as a mechanical coupling. तर मेकॅनिकल कपलिंग नसली असती तर हे सिलेंडर मधला हा पिस्टन पहिल्यांदा वर गेला असता, मग नंतर हेतला गेला असता. पण आपली रिक्वायरमेंट काय? irrespective of the load on a cylinder, we have to move both the piston simultaneously. For that purpose, we are connecting these two piston rods by using this mechanical coupling. So this circuit is called as a synchronization circuit. Now, when we are passing this fluid to the piston head side, irrespective of the load, these two pistons are moving simultaneously in upward direction or extension stroke. At that time, what happens? Whatever the fluid, it will be on a piston rod end side. इथलं फ्लुइड असेल आणि इथलं फ्लुइड आहे, हे काय येणार आहे? बाहेर पडणार आहे जेव्हा पिस्टन वरच्या डायरेक्शनने मूव्ह, and that will be combinedly passing to the port B, and from port B to port T, that is the tank. म्हणजे फॉरवर्ड मोशनला ए कडून इथं फ्लुइड येणार आहे, हे प्रेशर बिल्डअप करणार, पिस्टनला वरती ढकलणार. त्यावेळेस पिस्टन रॉडच्या साईडला जे काही फ्लुइड आहे ते इथून बाहेर पडणार, इथून बाहेर पडणार, आणि कंबाईन हे कुठे येणार आहे? बी ला, आणि बी कडून कुठे जाणार ते? टँक. इट इज फ्रॉम फर्स्ट पोझिशन वेअर यू आर ऑपरेटिंग दिस नॉब. at that time this position it will be in actuation. If you are considering this diagram where P port is connected to the B port and A port is connected to the T port, म्हणजे ही डायग्राम इथं कन्सिडर करायची. म्हणजे काय होणार आहे? हा पॉइंट म्हणजे काय? P, आणि हा पॉइंट म्हणजे काय? B. T is connected with the B and A is connected with the T. When P is connected with the B, at that time whatever the fluid from the pump, now it will be passing through this line from B port and it will be divided to the rod end side of the both of the piston. इकडे त्याच्यामुळे काय होणार आहे? हा पिस्टन डाउनवर्ड डायरेक्शनला मूव्ह होणार. इट विल बी मूव्हिंग इन अ डाउनवर्ड डायरेक्शन, और इट मे बी कॉल्ड एज अ रिट्रॅक्शन स्ट्रोक ऑफ द पिस्टन. ड्यू टू द रिट्रॅक्शन स्ट्रोक, इथं जे पहिलं फ्लुइड आलेलं होतं ह्या पोझिशनच्या वेळेस, दॅट विल बी कमिंग आउट फ्रॉम दॅट port, from that port, A port, here from first cylinder, from second cylinder, and combinedly it will be passed to the A port, and from A port to T port, A port to T port to the tank. Are you getting its operation? Synchronization with the mechanical coupling. Synchronization operation, it is required to move the piston, both the piston simultaneously, means you have to maintain the same speed of the both the pistons, right, irrespective of the load on the cylinder. So that is called as a synchronization of the motion, and it is achieved by the two types. That is the first one, mechanical coupling, and second there will be a flow dividing valve we are using. There are two methods by which we can carry out the synchronization. The first type we have just studied, that is the synchronizing with the mechanical coupling. Are you getting this circuit? What is the function of this circuit? What are the different elements of that circuit? How it will be operate? How extension stroke is to be carried out? And how retraction stroke is to be carried out? I have explained clearly. Is it any problem to anybody regarding operation, function of this circuit? Hello? Anybody have problem?
Sir,
Yes.
can you explain that mechanical coupling?
Mechanical coupling, it is a one part that will connecting these two rods, just like we have to connect the pipes, right? दोन पाईप आपल्याला जोडायचे असेल तर आपण कपलिंगच्या सहाय्याने जोडतो, बरोबर आहे का? हॅलो.
Yes, sir.
हा, त्याप्रमाणे हे रॉडला कनेक्ट करण्यासाठी ह्या दोन प्लेट आहेत अशा कन्सिडर करा, बरोबर? हा रॉड आहे, ह्या दोन प्लेट आहेत अशा वर आणि खाली ह्या रॉडच्या मध्ये, आणि नटबोल्टच्या सहाय्याने आपण पॅक केलेत हे दोन्ही. कपलिंग म्हणजे काय? ह्या दोघांना घट्ट पकडणारा एक पार्ट. येतोय का लक्षात?
Yes, sir. Understood.
जसं आपण बेसिक मेकॅनिकल इंजिनिअरिंग मध्ये ओल्ड लॅम्प्स कपलिंग वगैरे बघितले आहे का, किंवा फ्लॅंजेस बघितल्या, म्हणजे दोन पार्ट एकत्र जोडणारं जे डिव्हाइस आहे त्याला काय म्हणतो आपण? कपलिंग. फ्लॅंज कपलिंग आपण बघितलं, ज्याच्या सहाय्याने दोन पाईप आपण कनेक्ट करू शकतो, राईट? कपलिंग इज नथिंग बट these are the device, those are we may say connecting the two different things simultaneously, right?
Yes, sir.
Okay, take the time to draw this diagram, right? Everyone must have to draw this diagram. Take a 5 minutes. When diagram is over, reply please. Is it over?
Yes, sir.
I'm requesting A division student to write their roll number in chat box. The A division students, please write their roll number in chat box. Okay, A division is over. Is anybody remaining from A division? Okay, Divjyoti Sate is there?
Yes, sir.
Okay. Sunil is there? Sunil?
Yes, sir, present.
Okay. Sachin? Sachin Shirsagar?
Yes, sir.
Okay. Rutuja Tarapurkar? Rutuja is there? Hello? Praveen Samdar is there?
Yes, sir.
Deep Jyoti Sate is there? Right. Okay. Milind Jagdal is there?
Yes, sir.
Okay. Amol is there? Amol Sul?
Yes, sir.
Okay. Shraddha?
Yes, sir.
Kanaya?
Yes, sir.
Okay. Sachin Wagmare?
Yes, sir.
Okay. Yash?
Yes, sir.
Suraj More?
Yes, sir.
Komal?
Present, sir.
Paras?
Present, sir.
Mangesh?
Present, sir.
Rutik?
Yes, sir.
Prajwal?
Yes, sir.
Chaitanya?
Yes, sir.
काय चैतन्य आहे का चैतन आहे काय? What is your name? Preyesh?
Yes, sir. Yes, present.
हा? Sohail?
Present, sir.
Okay. Sohail?
Present, sir. Present.
Okay. Saurabh? Saurabh Sawan?
Present,
Okay.
sir. Present, sir.
Sunil? I think it is over. Bhushan? Bhushan? Okay.
Present, sir.
Prithviraj?
Present. Present, sir.
Okay. Adam? Adam Sheikh?
Yes, sir.
गाडीवर आहे काय?
Yes, sir.
Where are
Present.
you? Okay.
Yes, sir.
What about Tarapurkar? Rutuja?
Present, sir.
Okay. Now B division student, write your roll numbers in chat box. Is it over? All B division students, whether you have written your roll number in chat box. Nilesh?
Present,
Nilesh
sir.
Kadam? Okay.
Present, sir.
Vinayak?
Yes, sir.
Vinayak, okay. Akash?
Yes, sir.
Very good. Saurabh?
Yes, sir.
Prajakta?
Yes, sir.
Okay. Karuna?
Yes, sir.
Akash?
Yes, sir.
Pratik? Pratik Deshmukh, is it
Yes, sir.
from B division? Pratik?
Yes, sir.
Okay. Avinash?
Yes, sir.
Very nice. Yogesh?
Yes, sir.
And Avinash Dabade?
Yes, sir.
Okay. Good strength. Today's strength is a nice one, but we require more attendance. Whatever your friends, colleagues are there, please tell them to be remain present for each and every lecture, because I think your semester will be carried out through online only. So repetitive session may or may not be possible. You have to follow the video lectures and notes only, right? As far as possible, you must have to continuously attend the each and every lecture, right? Tell your friend to attend the lectures so that attendance is also improved for every subject. Okay, good strength. Now, there will be another method by which we can carry out the synchronization by using flow dividing wall. In previous slide, by using mechanical coupling. This will be the mechanical coupling. Now, flow dividing wall. This was the flow dividing wall. It consists of this variable fixed flow control wall. बरोबर आहे का? व्हेरिएबल नाहीये, कारण इथं काय आहे, एरो नाहीये, त्याच्यामुळे व्हेरिएबल फ्लो कंट्रोल वॉल म्हणायचं नाही याला, फिक्स्ड फ्लो कंट्रोल वॉल, राईट? This will be the check wall, one directional wall or non-return wall. It allows the flow only left to right. Right to left it will block. But in case of this wall, left to right it will be blocked. Right to left it will be allowed. Now, in this diagram, to carry out the synchronization motion of the both cylinder, we are using this flow dividing wall. Its name itself indicates its meaning. Flow divider means whatever the fluid coming from the pump, it will be equally divided to the each cylinder. Equally divided to the each cylinder. Right? Are you getting? Means by providing the flow dividing wall, we can synchronizing the motion. Now it will be provided at the inlet of the each cylinder. So extension stroke, it will be only synchronizing. If you have to require the synchronization of a retraction stroke, downward stroke, at that time you have to put same flow dividing wall at this return line also, right? Now it will be having the same function like a mechanical coupling, but instead of a mechanical coupling, in this synchronization circuit, we are utilizing this flow dividing wall or flow divider. Flow divider is a combination of a flow control wall along with the check wall, and it will dividing the flow equally to each cylinder, right? Now it will consist of a remaining part of the base, that is the pump, then filter, then tank, pressure relief wall, pressure gauge. Then from pump, then this will be a 3x2 direction control wall. There are 3 positions: solenoid operated, spring return, 4x3 direction control wall, right? 4-port 3 position, right? When this will be the central position, it will be the off position or null position, where the fluid, pressurized fluid from the pump, it will be passed to the tank, return to the tank. Now when this position is to be actuated, what happens? From pump to port A, from port A, it is divided, some part to the this flow control wall and some part through the this flow control wall. Now this flow, when it is passing to this direction, it will allow, then it will become here, then it will be passed or divided from this point. But it does not allow in this direction. It must become in downward direction. समजते का पहा? पंप कडून हा फ्लो आलाय, इथे येईल सेंट्रली. इथून हा फ्लो डिवायडर काय करेल? 100 युनिट लक्षात घ्या. फ्लो 100 युनिट आहे. युनिट मध्ये लिटर पर मिनिट असेल, लिटर पर सेकंद असेल किंवा मीटर क्यूब पर मिनिट असेल. काय जे काय असेल तो फ्लो 100चं 50-50 मध्ये डिवाइड केलं. हा इकडे येईल, इथून इकडे येईल. काही अंशी तो इकडे यायला पाहिजे, इकडून तो अलाव करेल, पण तो पुन्हा इकडे येणार आहे, पुन्हा इकडून इकडे जाणार आहे. पण हा इकडून इकडे मात्र नाही जाऊ शकत, बिकॉज हा चेक वॉल काय वन डायरेक्शन वॉल आहे. हा इकडे फ्लो अलाव करत नाही, हा इकडे अलाव करत. जेव्हा हा फ्लो इकडून हा फ्लो कंट्रोल वॉल मधून जाईल, 50 पैकी 45 इकडे गेला, 5 हा इकडे आला, इकडून इकडे जायला पाहिजे तर तो ब्लॉक होईल. त्याच्यामुळं इकडून आलेला 5% फ्लो इकडे येईल, पुन्हा हा इथूनच इकडे येईल. आर यू गेटिंग? फ्लो डिवायडिंग, वर्किंग ऑफ अ फ्लो डिवायडर वॉल. म्हणजे हा काय करतो, 100%चं 50-50% मध्ये इक्वली डिवाइड करतो सगळ्या दोन्ही ह्याला. राईट? So this fluid now it is passing. Now here which type of a wall? Again this will be direction control wall. Which type of this wall?
2x2 direction control wall.
Right, 2x2 direction control wall, solenoid operated and spring written. Right? Okay. Now when the fluid it is coming from this A port, dividing this fluid to the left hand side, it is passing through this check wall. Right? This is a open because it will allow the flow only in upward direction. Reverse direction flow is to be block 1. So whatever the fluid coming from this side, it will be passing here, then on a piston end of the cylinder. So this piston it will be moving in a upward direction. Same process it will be applicable for this second cylinder or right hand side part. Whatever the fluid coming from the pump from port A, it will be passing through this flow control wall, then it is passing through this check wall to the piston end, piston head of the cylinder end. Right? So both the pistons are moving in a upward direction. Right? Both the pistons moving in a upward direction. And whatever the fluid which is on a rod end side of both the cylinder, इथून fluid इथे येणार आहे, रॉड एंड साइडचं फ्लुइड इथे येणार आहे. तेव्हा जेव्हा हे दोन्ही पिस्टन अपवर्ड डायरेक्शन मूव्ह होतील आणि हे कंबाईनली कुठे येईल, इथे येईल, इथून ह्या पोर्टला येईल आणि हा पोर्ट ही पोझिशन जेव्हा ऍक्टिव्हेट होईल तेव्हा हा पोर्ट आणि हा पोर्ट कनेक्ट केलेला असेल, तिथून हे खाली येईल. आता रिव्हर्स पोझिशन पण, when this position is to be in actuation at that time, port P is connected to the B and A is connected to the tank. So whatever the fluid from the pump, it will be passing to the B. Then from this, it will be passing towards the rod end of both cylinders, first, second cylinder. Because of that, now this cylinder is moving and this piston is moving in downward direction. This piston is moving in downward direction. Retraction stroke is to be carried out. At that time, what happened? Whatever the fluid which is present on a piston head side of first cylinder, piston head side of the second cylinder, it is coming out where that flow is to be blocked. Where that flow is to be blocked. समजतंय का? जेव्हा हा पिस्टन खाली येईल तेव्हा पिस्टनच्या हेड कडल्या साईडचं जे फ्लुइड आहे ते इकडे रिटर्न यायला पाहिजे, इथून रिटर्न यायला पाहिजे, पण हा फ्लो काय आता ब्लॉक आहे. त्याच्यामुळे इथलं प्रेशर काय होतं, वाढत जात. मग हा सॉलिनॉइड ऑपरेटेड वॉल आहे, बरोबर आहे. तो हे प्रेशर सेन्स करतो आणि ही पोझिशन शिफ्ट करतो. मग तेवढं ज्या काही प्रेशरला सेट केलेला आहे तो वॉल तेवढं ऍक्टिव्ह झालं की ही पोझिशन इथं इन लाईन येते. So this flow path it will be connected one. Are you getting? So whatever the fluid from the piston head side, now it is passing to this. From this, it instead of going through this flow control valve, it is directly passing through this check valve. It allows the flow, free flow in this direction, left to right, from this here and from here to tank. Similarly, for this diagram, ह्या पिस्टन हेड साइडचं जे काही फ्लुइड आहे ते इथे येईल. जेव्हा पिस्टन खाली येईल तेव्हा इथून हे फ्लुइड प्रेशर वाढेल, याच्यावरलं हे इथून बाहेर पडेल, ह्या चेक वॉल पाशी येईल. हा क्लोज पोझिशन मध्ये, इथलं प्रेशर बिल्टअप होत जाणार. काहीतरी प्रेशरला हा वॉल सेट केलाय सॉलिनॉइडनी. हा सॉलिनॉइड ऑपरेटेड सिग्नल घेणार, 12 बार प्रेशर जनरेट झालं की ही पोझिशन इकडे शिफ्ट होणार, म्हणजे हा फ्लो कंटिन्यू होईल. इथून आलेलं फ्लुइड इथं येईल, इथून इथं, इथून इथं, इथून इकडे येईल. गरज नाही त्याला की रिस्ट्रिक्टेड फ्लो मधून जायचं, तो ह्या चेक वॉल मधून जाईल. बिकॉज चेक वॉल इज अ फ्री फ्लो वॉल, म्हणजे फ्लो कंट्रोल वॉल मधून जायच्याऐवजी हा चेक वॉल मधून जाईल. दोन्हीकडून आलेलं फ्लुइड इथं कंबाईन होईल, इथून ते या पोर्टला येईल, बी पोर्टला. फ्रॉम बी पोर्ट टू ते टी पोर्टला येईल. आर यू गेटिंग दिस? वर्किंग ऑफ द synchronizing with flow dividing wall.
Yes, sir.
Okay, draw this diagram. Is it over?
Yes, sir.
Anybody from boys? Where the diagram is
Yes,
over?
sir.
Okay.
Yes, sir. Yes, sir.
Now, this is a counterbalancing circuit, right? Counterbalancing circuit means when the position of the cylinder it is a vertical one and the load it is applied on bottom side, right? म्हणजे काउंटरबॅलन्स सर्किट ह्याचं काम काय आहे की हा जो लोड आहे हा एका पर्टिक्युलर पोझिशनला पिस्टनच्या पोझिशनला लॉक करून ठेवणं गरजेचं असतं. आता एरवी बाकी पहिल्या सर्किट मध्ये आपण काय केलं होतं, लोड इट इज ऑन अपवर्ड साइड, सो रायझिंग इट इज अ इझियर वन, राईट? वेट पण आहे आणि बिकॉज ऑफ अ ग्रॅव्हिटी खाली येताना त्याचं स्पीड पण वाढणार आहे. पण अशा वेळेस जर तुम्हाला हा लोड एका पर्टिक्युलर पोझिशनला जर तुम्हाला लॉक करायचा असेल तर तुम्हाला काउंटर फोर्स त्याच्यावरती अप्लाय करणं गरजेचं आहे. म्हणजे व्हॉट इज द फंक्शन ऑफ दिस काउंटर बॅलन्सिंग सर्किट? इट विल बी ऍप्लिकेबल फॉर द लोड वेअर सिलेंडर इट इज इन व्हर्टिकल पोझिशन and we have to locking that load when it is to be in lowering motion or when it is to be lowering one, right? म्हणजे तो खालच्या डायरेक्शनने लोड अप्लाय केलेला आहे, अप्लाय होतोय आणि असा लोड तुम्हाला एका इन्फायनाइट पोझिशनला जर लॉक करायचा असेल, वेअर इज इट टू बी यूज? इफ यू कन्सिडर लिफ्ट, राईट? लिफ्ट मध्ये आपण वरती जाताना काही प्रॉब्लेम नाही, खाली येताना 5व्या 10व्या मजल्यावरून खाली येताना लिफ्टचं पण वजन आहे त्याच्यामध्ये, आपण पण उभे आहोत आणि आता 10व्या मजल्यावरून आपल्याला 5व्या मजल्याला थांबायचंय. मग त्यावेळेस त्याला कुठेतरी लॉक केलं पाहिजे, काउंटर बॅलन्स केला पाहिजे तो फोर्स. ऍट दॅट लोकेशन वी आर युजिंग दिस काउंटर बॅलन्सिंग सर्किट. नाउ व्हॉट इज दिस काउंटर बॅलन्सिंग सर्किट? इट कन्सिस्ट ऑफ अ काउंटर बॅलन्स वॉल, right? This will be a pilot operated check valve, right? This is the pilot operated valve, pressure control valve along with the check valve. It will be mounted on a return line of the cylinder. How it will be operated? If you are considering, this will be the reservoir first. We may use the filter over here, pump. This will be the direction control valve, 4/3, 3 positions, 4 port, 1, 2, 3, 4, 4/3 direction control valve. Then this will be the cylinder, this will be the piston, this will be the load mounted on a piston on a bottom side, right? Now this will be the whole assembly. It will be called as a counterbalance valve. It will consist of a pressure relief valve with a pilot operated spring return along with the check valve. This whole assembly it will be called as a counterbalance valve. Are you getting? In center position, second number position, it will be null position, where whatever the discharge coming from the pump, it will be again connected to the redirected to the tank. In first position, what happened? Whatever the fluid sucked by this pump, it will be discharged from P to A port, A port to upper side, piston head side of the cylinder, where that fluid, pressurized fluid, it will be stored. Again we are supplying the fluid, so pressure is built up in this chamber. It will moving this piston in downward direction. म्हणजे इथूनही प्रेशर येते आणि हा लोड वेट ह्या लोडमुळे ही डाऊनवर्ड प्रेशर ऍक्ट होणार आहे, त्याच्यामुळे ह्याची मुवमेंट मात्र फास्ट राहणार आहे, राईट. बट वी हॅव टू लॉक दॅट मुवमेंट, वी हॅव टू lock that movement at a particular pressure range, right? For that purpose we are providing this counterbalance assembly at a return line in order to produce counterbalancing force. ह्याला लॉक करायचं असेल तर इकडून तो फोर्स अप्लाय झाला पाहिजे, बरोबर का? त्याला अडवणारा फोर्स, काउंटर बॅलन्स करणारा फोर्स तिथं राहणं गरजेचं आहे, राईट. When this piston it is moving in a downward direction and we have to keep this piston at a particular location in this region. At that time we use this counterbalance force. Now what happens, whatever the fluid, it will be in a rod end side of this piston. Now it is passing through this path. हा वॉल काय आता क्लोज पोझिशन मध्ये, काउंटर बॅलन्सिंगला जेवढं काय प्रेशर पाहिजे तेवढं प्रेशर अचीव होईपर्यंत हा क्लोज पोझिशन मध्येच राहणार आहे. इकडून आलेलं फ्लुइड इथून तर पुढे जाणार नाही कारण हा क्लोज आहे, जास्तीत जास्त इथून चेक वॉल मधून यायला पाहणार, इथं पण तो बंदच आहे, राईट. म्हणजे हा लोड ह्याच पोझिशनला आता काय राहणार आहे, स्टिक राहणार आहे, कॉन्स्टंट राहणार आहे, right. Whenever the pressure within this chamber it will be reaching at a set pressure, at that time this pilot signal is given to this wall, so this wall it will be get connected and fluid is discharged to the tank. Are you getting? समजतंय का?
Yes,
ओके.
sir.
म्हणजे काय, पंप कडून फ्लुइड येणार, पिस्टन साइडला ह्या सिलेंडर मध्ये ते कलेक्ट होणार, त्याच्यामुळे काय होणार, इथं प्रेशर जनरेट होणार, हा पिस्टन खाली यायला पाहणार, त्याच्यामुळे पिस्टन पोझिशन फॉर्म राहणार एका
फोन पण काय उचलला सर्व.
जाऊ दे ना आता.
लिव्ह करायचा का?
फोन बी उचलणार ते. त्यांना माहितीच नाही का की बनतो. एक मिनिट आणि एक करतो. काय कॉल उचलणार कडे सर.
काय करायचं सचिन?
तेच काय कळना.
लिहून टाकू मग काय करायचं आता,
हो
सर पण
सचिन.
फोन उचले ना म्हणजे.
मग देशमुख बोला.
काय रे सरला?
काय फोन उचले ना तर काय त्यांना माहित नाही काय लिव्ह झालं त्यांची बडबड चालू दिसते.
करायचं का लिहू का थांबायचं?
थांबा की 2 मिनिटं.
पण त्या आवाजाला काय झालं रे? सचिन सांगा लवकर बघा काय करायचंय.
1 मिनिट.
कसल्या आवाज आला?
जाऊ दे नंतर बोलू, रेकॉर्डिंग चालू आहे.
काय झालंय?
हॅलो.
हम्म.
ते कॉलेजचं नेट बंद पडलंय बघू मग हल्ली लिहू हा बघू कोणाला दुसरी लिंक पाठवतो.
बर बर.